All right. Let's talk about ellipses again. First of all, what I want you to realize is that planets, thank you. I'm trying to think of the word, orbit in an elliptical pattern. Okay? And so there's one way that ellipses are important. They're not just, something I'm forcing you to do for no reason. Planets do orbit in elliptical patterns. All right? Let's talk about how we graphed parabolas on Friday. What were the things that we needed to identify before we could graph it? We need the center because that gives us H and K. We identified H and K and we plotted the center. Then what? Before we got to the foci, what did we identify? Okay, we needed vertices, right? And what values in our standard equation did we pick out? A and B. We picked out A and B so we could plot our major vertices and then what we're going to call our minor vertices. Okay. Then we looked at our foci. What did we need to identify to get our foci? We identified C. Now, if we are going to work backwards and write our standard form equation, okay, our standard form equations are either going to be x minus h squared over a squared plus y minus k squared over b squared equals 1, or x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, those are our standard form equations. So if we are going to have to go and write those equations, we at least need H, K, A, and B, okay, to be able to fill all that in. Now, how are A, B, and C related? Okay, C squared equals A squared minus B squared. So C could help us if we know an A or a B. Okay? We also know some information about how long the major axis is. How long is the major axis of an ellipse? How long would this be? Well, how long is it from here to here? Here to here is how long? A. So how long would all of this be? 2A. How long would the minor axis be? 2B. Okay? These are all different pieces of information that we could get about the graph to have to write our standard form equations. Okay? So let's look at some examples. Our first one, I am giving you that the vertices are at 6, 0 and negative 6, 0. And the foci are at positive 2, 0 and negative 2, 0. Remember, if it says vertices, that's talking about the major vertices. Okay? Here again, with these, what am I going to make you do? I'm going to make you plot these points so you can get an idea of what your picture is going to look like. Okay? So at 6, 0 and negative 6, 0, we have vertices. At 2, 0 and negative 2, 0, we have foci. what direction is our ellipse? We have a horizontal ellipse. So I'm going to go make a note to myself that I need x minus h squared over a squared plus y minus k squared over b squared equals 1. All right. So what are some pieces of information we can pick out from our graph right now? Do we know where the center is? Where's our center? Okay. We can say that our center is at 0, 0. Okay, because it has to be in between the vertices. Right? What else can we pick out? A, what is A? 6. Our vertices are 6 away from our center, so A is 6. Jenna, why is C 2? Okay, both foci are 2 away from our center, so C is 2. Now, for our standard form equation, we need HK, which we have. We have A, we need B. Luckily, we have C to help us, right? We know that C squared is A squared minus B squared. So C squared would be 4. A squared is 36. So do you agree that B squared would be 32? Okay. I'm going to go ahead and leave it as B squared because that's how it looks in our equation, doesn't it? Okay. So I'm going to go back up here to standard form. We know that H and K are both 0, so we have x minus 0 squared and y minus 0 squared. Our A is 6, so x squared is going to be divided by 36. B squared is 32, so y squared is going to be divided by 32 equals 1. Question. All right, look at another one. Our foci are at 0, 0, and 4, 0. Our major axis has a length of 8. So at 0, 0, we have a foci. At 4, 0, we have a foci. And our major axis has a length of 8. Okay, let's just start with the foci here. Can we determine the center if we have both foci? Okay, where's our center? So our center is at 2, 0. This also means what about our ellipse? What direction is it? This is a horizontal ellipse. Okay. All right. One more thing we can pick out from this picture before we worry about the major axis. These two. Very good. All right. Now, our major axis has length 8. Which means what about our vertices? If our major axis has length 8, how far away are our vertices from the center? They're going to be 4 away. Okay. And so what does that mean? A is 4. Very good. Okay. Are we ready to write our standard form equation? What do we need? We need B. All right. We know that C squared is A squared minus B squared. We know C is 2, so C squared is 4. We know A is 4, so A squared is 16. What does that make B squared? What? B squared would be 12, right? Okay. So I'm going to go ahead and leave it as B squared because that's all we need for our equation. Don't worry about solving it and then having to square it later, okay? Save you some time. So our center is at 2, 0, so we're going to have to write x minus 2 squared and y minus 0 squared. A is 4, so A squared is 16. B squared is 12. This means equal 1. Questions? Excellent. Third example. Okay. Our ellipse has a center of 3, 2, A equals 3C, and the foci are 1, 2, and 5, 2. All right, so here's our center. Since they gave us our center, I'm going to go ahead and make a note that HK is 3, 2. All right, A equals 3C. We'll wait to use that information. And then our foci are at 1, 2, and 5, 2. Okay. First of all, what does that mean about the shape of our ellipse? I really like the horizontal ellipse, apparently, huh? I promise we'll see a vertical one. Okay. What else can we pick up from our picture? What is C? C is 2 because our foci are 2 away from the center. All right, how did you get that? Okay. A is 3C. If A is 3C and C is 2, then A has to be 6. Now what do we need? B. All right. How about you find me B squared? What is B squared? b squared is 32. So we can write x minus 3 squared over 36 plus y minus k squared over 32 equals 1. Oh, I should probably write that as a 2 instead of a k, huh? Any questions so far? All right. Last example. We have vertices and eccentricity. First of all, what does the eccentricity measure? How oval it is, right? So eccentricity is always going to be a number between what two values? 0 and 1. The closer to 0 it is, the more circular. The closer to 1, the more oval. So right now we're kind of right in the middle. All right. So let's talk about, first of all, our vertices. Our 0, 8 and 0, negative 8. What can that tell us? Okay, first of all, it's vertical. So now we're going to have x minus h squared over b squared and y minus k squared over a squared. Right. The center needs to be at the origin because it is in between our vertices. Okay. What else? A is 8. Okay. Okay. How do we find eccentricity? Okay. Eccentricity is C over A. All right. Our eccentricity is 1/2, and we know that A is 8. Oh, I just did that backwards, sorry. We don't know C, A is 8. There we go. So what does that make C? 4. And once again, we don't have our B value, do we? Okay. So our B value, let's see, C squared is A squared minus B squared. C squared is 16. A squared is 64. What does that make B squared? 48. Would you agree? All right. So our center's at 0, 0, so we have an x squared and a y squared. This is vertical. A squared is 64, has to go with the y squared. B squared is 48 equals 1. Here's your homework.